Okay, let's get going on this, okay? So what we're gonna do, this first question here, right? Well, our second question says determine whether x minus 5, so this right here is a factor of this. All right, we know how to do that now. We just talked about that. So we'll practice that again. Then find the remaining factors of the polynomial. Okay, well, I will show you how to do that, and you'll be happy to know that you already do know the skills of how to do this and how we're going to do this. But this will be a good refresher because it wasn't necessarily something that was easy for a lot of people. All right, so what we're going to do is we're going to set up our synthetic division. So I'm going to go 5, right? That's what I'm dividing. It's going to be positive because it's the opposite of this. And then if I go, all right, this is my 1, this is my 2, this is my 3, or sorry, I'm writing that all goofy. So this is my third one going down to 1, 0. So I got numbers for all of these that are accountable, right? So if there's no variable, it's always 1. So we got 1, we got -7, we've got +7, and we've got 15. Okay, so we're going to leave some space. I'm going to put our little box for the remainder, which we hope is going to be 0, right? Because if it is, then we can keep going. All right. So first thing, bring this down, right? That's the first step of synthetic division. 5 times 1. So we're going to multiply and add, multiply and add. 5 times 1 is 5. -7 plus 5 is -2. And then you go 5 times -2. Remember, positive times a negative is negative. So you get -10. And then that gives us -3 because the negative number is larger than the positive, which means your answer is negative. And then just treat it like a subtraction problem. Just go 10 minus 7. And then you get your answer. All right, 5 times -3 gives me -15, and this worked out. Okay, and so now that means my depressed polynomial is this, is my x squared minus 2x minus 3. Okay, and so I know one of my factors, right? One of my factors is x minus 5, okay? And if I were lazy, I'd stop and say, okay, here's my factored form of this. But the thing is, I got to check and see if I can factor this, right? I got to say, is this factorable, all right? And now, when it's a quadratic and you don't know like what factors you should be testing or something like that, then you can't really use division with this. So we're going to go back to our good old friend, which is the AC method. Okay, and remember the AC method states that you multiply A times C, all right, and then you get AC, right, whatever that number is, and then you want to find 2 factors of AC, right, of the product of AC that add to your B term, all right, and your B term is this one right here. So that's kind of how this works, right? And we've done this, all right, and so we're going to start with AC, so we're going to go 1 times -3, okay, 1, -3. Those are your 2 terms. Remember, this is a quadratic, right? And this is of the form ax squared plus bx plus c. So that's where we're getting that a, b, and c from. If you forgot about that, or you just woke up from a coma or whatever's going on, right? That's where we're at. So 1 times -3 is -3. Now I need 2 factors of that add up to -2. All right, and so think about all the possible factors of -3. Now this is, again, where you need to remember that in order to get a negative product, you have to have a negative and a positive, right? And that's the only way you can get it. And so there's really only 2 choices here. You could have -1 and +2, or sorry, -1 and +3, being stupid here, right? And that multiplies to -3. And it adds to +2. So then the other case would be if I make my 1 positive and my 3 negative, that multiplies to, that does multiply to -3, so they're a factor pair, but this one adds to -2, which is what we want. So we're going to use these. All right, and then we're going to use our factor by grouping. So we're going to rewrite this quadratic by decomposing this, right? So this is kind of an informal review of how do we do this, right? So you're going to go x squared plus x because the 1 goes there, right? You could put the 1 there, but we don't need it. we know it's there, minus 3x, and then minus 3. So I just took this and I rewrote it with these terms here, and I got those terms from this. Okay, so just a reminder. All right, now let's factor by group, right? So draw your little fence there. So I can factor an x out of this first one, and I get x plus 1. And that means that I'm going to get x plus 1 over here if this works. And so what do I have to multiply by x to get negative 3x? Well, negative 3. And then check it to make sure it gives you this term, and it does. So now I can pull an x plus 1 out of both of these. And then I can put the leftovers, as I like to call them, in the other term. And so these are the factors of this. So when I do the total factors, all right, when I do my total factors, I have to include my first factor, which is this one. So I'm going to have x minus 5, and then we're going to write these guys. And then we have x plus 1 and x minus 3. And I'm not sure if there's like a convention of like how you're supposed to write these things, what sort of order. I'm guessing there is, but we're not going to worry too much about that. So this is your final answer, and that's how this works. So hopefully this serves as a good reminder of how the AC method works, and why we learned it, right? And why it's kind of important. Okay, so I'm going to stop the video, and we will have one more video going over factoring something that's a little larger and doing this synthetic part twice.